Welcome to this channel. We are looking at velocity time graph. This episode, we are going to explain to you where can we have the acceleration, where can we have the constant velocity, and where can we have retardation, and then how to calculate total distance covered. These are the things we want to discuss in this episode. And to do that, we need to back it up with series of questions. When you have velocity time graph, you're going to have velocity on the vertical, that's on the y-axis, and then you're going to have your time on the horizontal. You need to indicate the units of velocity. You need to indicate the unit of time. And then the body starts on rest, then it's going to accelerate. So this way we are going to have your acceleration, probably for certain time. You can call this one T1. Then you're going to have, for that, you're going to have what? Your velocity at this place. And then you have your constant velocity. Here, velocity is constant. In that case, acceleration is what? 0. Okay, for another time, the body comes to rest. So this is where we have your retardation. This is where you have your acceleration. Can we make this one T2, T3? To really explain this episode, we need to look at questions for better illustration. A bus moves from rest with a uniform acceleration of 2 meters per second for the first 10 seconds. It then accelerates at a uniform rate of 1 meter per second square for another 15 seconds. It continues at a constant speed for 70 seconds and finally come to rest in 20 seconds by uniform deceleration. Draw the velocity time graph of the motion using the information given above. From your graph or otherwise, calculate 1. The total distance traveled, 2. The average speed for the whole journey, 3. The average retardation as the body is brought to rest, and finally the maximum speed attained during the motion. The question is lengthy, but it's very simple. What we're going to do, we're going to draw the velocity time graph. So this is how the velocity time graph look like. You have your velocity on the vertical, meter per second, and you have your time on the horizontal, that's t in seconds. For indicating velocity with the units, there's a mark for that. Time, seconds, there's a mark for that. And you are told that the body works. The body moves from rest, that's 0 here, with a uniform acceleration. This is where you have your acceleration, and is what? 2 meters per second square for the first 10 seconds. Then you indicate your time. You don't need to put seconds there because we know that anything you put on this horizontal line is in seconds. Then something is missing here. Before we go on, something is missing. We need to have the specific velocity for that duration, and that will take us to this formula: v equal to u plus at. The body starts from rest. That means u is 0. Acceleration is what? Acceleration is 2, and the time is what? 10. So that's 20 meter per second. So this place is what? 20 meter. We don't need to put meter per second, but I've informed that anything you put on this vertical line is in meter per seconds. Then we can go on with the question. It then accelerates at a uniform rate of what? 1 meter per second square for another 15 seconds. Then we are told it then accelerates at uniform rates of 1 meter per second for another 15 seconds. So if you look at that acceleration, there's a reduction in that acceleration. So instead of continuing straight, it won't do that. There's going to be a bend to show that reduction. It's going to bend for another what? For another 15 seconds. Okay, so you're going to add that 15 plus 10, making 25. Okay, but the interval from here to here is what? Is 15. Okay, is that clear? Then the next thing to do is to get the corresponding speed at that time. So let's get that. So that will be equal to v equal to the initial velocity is going to be where it stops here, which is what? 20 plus acceleration is 1. The time is 25. The time is interval between 10 and 25, which is 15. So we're having 35 for this place. Let me repeat that. The acceleration is 1. Okay, so that will be bent because there is a reduction in that acceleration. So it won't go straight to bend for the what? For 25, for 15 seconds. So I said you add it to the first one, making 25. Then it continues at a constant speed for 70 seconds. So it continues at a constant speed for 70 seconds. So 70 plus 25, that's 95. When the speed is constant, acceleration is what? Is 0. So there's no acceleration in this place. The speed is constant. Finally come to rest in what? In 20 seconds. Finally come to rest in 20 seconds. So 20 plus this one, 115. So the interval from here to here is what? Is 20. The interval from here to here is 70. Okay, so that's that. Once again, come to rest in 20 seconds by uniform deceleration. Okay, so this is where you have your deceleration. This is your deceleration. That's the place for deceleration. That's the place for constant speed. Acceleration is 0 in that place. So that's what we have for that question. That's what we have for that question. If you cannot decode the statement, if you cannot transform the statement to graphical form like this, you can't answer the question. That is a fact. So then the next thing to do now, draw the velocity time graph of the motion. That one is done. We've done that one. That one is done. Then the next thing is to calculate the total distance traveled. So that's what we want to do now. Total distance traveled. We are going to do that. We are going to look at the geometry, the shape. We're going to find the area of the shapes. Okay, I'm going to call this one first diagram here. We're going to find the area of this place plus the area of this place plus the area of this place plus the area of this place, and that will make the total distance. And don't forget the shape 2 is trapezium. The shape 1 is triangle. The shape 3 is a rectangle. The shape 4 is triangle. 1, that'll be half base times height. The base here is 10, half times 10, and then times the height from here to here. That's 20. Okay, so that's giving us 100 meter. That's a shape 1. For shape 2, shape 2 is a trapezium. Okay, where the two parallel lines here and here, they are A and what? And B. So here, from here to here is my A. That's 20. That's equal to 20. From here to here is 35. That's my B. So area of 2 for 2, that's area of trapezium. The formula for area of trapezium is half times A plus B, and then times height. Okay, that will be equal to what? Half times my A is what? My A is 20. My B is 35, and then my height is from here to here. The interval between here and here, which is what? Which is 15. Okay, this is 35. So if you do all this, it's going to give you 412.5 meter. That's for the second shape. For the third shape, is rectangle, which will be equal to length times breadth. The length here is from here to here. The interval there is 70, and then the breadth from here to here, that's 35. Okay, so that will give us, if you multiply these two, that will give us 2450 meter. For the shape 4 is triangle. That's half base times height. My base is the interval from here to here. That's 20, and then my height is from here to here. That's 35. So 2 here 1, 2 here 10. I have 350. Okay, meter. So let's do the total together. So if you do that, the total distance will be equal to 3,312.5 meter. That's your total distance. That's the area of 1 plus area of 2 plus the area of 3 plus area of 4 will give you the total distance, which is what? Which is this. The second one, we need the average speed, which is the total distance taken over total time. So the total distance we have is this one here. Total time, check your diagram from 0 to what? 115. So if you do that, you're going to have 28.8 meter per seconds. The third one, for the retardation is gotten when the body comes to rest. Okay? And that will be acceleration equal to what? Change in velocity over time. The final velocity when the body comes to rest is 0 minus your u at the point of coming to rest. That velocity in that place is 35 over what? The time interval, okay, that it used to come to rest is 20. So that will be what? Minus 35 over what? Over 20 meter per second squared. Okay, so that's average retardation. And the negative show that the body is what? Is retardating, is decelerating. So that is correct. The final one, the maximum speed attained. The maximum speed attained during the motion. Check your diagram. The maximum speed attained is what? Is 35 meter per seconds. And that's that on this question. Quickly smash the watermarks on the video and subscribe. Don't stop there. Click on like button and begin to share the links of this video on all your social media platforms. Thank you for doing that.